All right. So in this section for week 2, categorical data, we're going to continue what we did before with data analysis, right? So I'm just going to repeat what I'd shown to you earlier before, which is well, here we have the module, and here's some other things to know. Oh yeah, we have the quizzes. I want to take us straight to the problem set. Hold on for a second. Contingency tables. Actually, I'll just take us to assignments. Here, hold on for a second. So remember, the problem set is the one that's due Thursday. This is the one that will be graded. And this is the one where we actually ask you to download an R data file and a script file. Come on. My computer's slow today. All right. And by the way, if there was an error in this right here, was there an error here, Malar?
No, it was in the class video actually.
Got it. Okay. Oh, this is a quiz or this is a problem set? Ah, no, this is the problem set. Let's see. Where do we have the
Yeah, problem set? Yeah.
What does it say? Sorry, hold on. I'm sorry. This is a quiz. Hold on. Why am I not seeing this?
Yeah, it's a rounding problem only. So if the data scientist, like we do the rounding issues, like we take it as rounding in a different way. Like the numbers are different. So as you say, instead of 100, 101 is coming.
Yeah,
so
yeah.
It will totally make the graph like go wrong, right?
I'm not sure what you're talking about, but let's talk about that later. We'll bin that, okay? I think let's take a look at the big picture here. The big picture here is to download the data and to actually understand the analysis that we're doing, and to know what a Mosaic plot is, and to know what contingency tables are. So here we have the R data file. Remember, this is a data set, and here we have the code. And just to do this, we're gonna let's download these. I'm gonna just click. Click these once. You can see I downloaded it here, and then we're gonna click the R code. We'll download this here. Notice we have these available for you. We're gonna here. I'm gonna go to my oops, sorry. I'm gonna go to my RStudio here. So I'm gonna switch to RStudio, and I'm gonna share my RStudio screen. And here we have what we should have here, actually, at least. It's getting a little confused, but we're going to share this to our desktop. So we're going to share our script to the desktop. Hold on. And we're just going to create a new folder. I called this before. You should have some meaningful name. I call this piece set 1, problem set 1, and we'll save it. Well, we'll open it in that file, and then we'll save. Okay. Notice that I made a couple changes here, but that's all right. All right. And this Titanic data set, let's make sure we save this one as, let's close this one. And if we go to our desktop, we should actually see a folder called problem set 1, and I'll show you how to do that. But I know we have that right now because I'm going to show you something. I'm going to print. Oops. What did I just do? What? I'm not sure what I did.
You went back.
Whoa. You know, I don't think I've ever done this before. Hold on for a second. View. Huh. Panes. Show all panes. Okay, that's never happened to me before. So apparently, you can make it so that you don't see all 4 panes. But what you see right now should be what the RStudio interface looks like. What I wanted to type was, if you get the working directory, you just type this little function, getwd, open close parenthesis, you'll get this working directory right here. Well, we don't really want to be there because we know that our working directory, at least I know where our folder is, which is actually desktop and then pset1. And then we should get, I think this is what it is. Well, I didn't do that right. Hold on for a second. Let's see. Get working directory. Oh, I know why. I need to set the working directory here. Set working directory to this little section right here. Okay. So this is what I basically did. And I showed you this in the last video. Last section. You download from the course website the R syntax, which has the suffix .r, and then you download the data set associated with that data analysis, which is the R data file. And I always recommend you put that on your desktop. It's easier for it to see. And I would say name it something that's easy to remember that doesn't have any spaces. I like pset1, for example. So that's where we are. And you should have something that looks like this. Now we can open our data frame, right? Because we don't see that here. We see something here, which is basically, in my version of RStudio, you can actually see the last commands, last functions, basically what you did in the last function. You probably wouldn't see anything. Otherwise, we actually don't have the data loaded. But that's okay. Because all we have to do is you go File, we're going to do Open File, and then you're going to go here, you're going to click Open here. It'll ask you, are you sure you want this to your global environment? And you say yes. And look, the nice thing about R is when you use the drop-down menu or the GUI interface, graphical user interface, you get what you need. And already is one thing, though, and a student had run into this problem before. Everything in our class, and most everything you do in R, will require you to do 2 things. One is to install a package, which is what I showed in the R tutorial. I see someone has a question. Basically, the first step here is, a student mentioned this on the discussion board. Make sure you always install the package, but you only have to do that once. And to run your script, you just highlight it, and then you click Run. And remember, you only have to install packages once. And this requires your program to be web aware. What does it mean? To be connected to the internet. Because here what we're doing is we're connecting to the internet. We're installing the package. And it has a bunch of other things attached to it. And this takes a little while. But then after you do it once, you don't have to do it anymore. It'll tell you where the packages are installed. But once you do it once, we're all okay. We don't have to worry about this anymore. So now that we've done it, let's just not worry. And we're going to comment it out. I put a little hashtag in front of it. And now the thing you need to remember is every single time you do a new analysis or reopen R, and you have to use this library function, and you have to tell R, okay, even though I have installed the package, now I'm going to use it. So you have to load the R package, and you use this using the library function. Notice that here, basically all you have to do, all you have to do here is you just type in the package with an in the name in quotes right here. You don't have to. I actually don't think you have to do it in quotes, but it's good practice anyway. So that's the thing that another student had encountered that was a problem. I think they tried to use the tally function, but they realized, but you can't use the tally function or any of these other subsequent commands because they require you to load the Mosaic package. You have to tell R, hey, I want to use this package so I can use the commands that are based on this package. So let's run that. Someone had asked whether anyone notices errors during the library Mosaic package installation process, whether or not there's a problem. Okay. Right, so, good question. I like this, Antoine. Antoine asked a good question. What's the difference between using library and require? You can also do this, by the way. This is the thing with R, and I keep saying this over and over again. One of the interesting things about R, and probably one of the most vexing parts of R, is that there's so many ways to do things. This is why, you know, talk to your friends who are using R. I always love to see people's script. I was working with someone yesterday. I wanted to see how he did his code. In some ways, I think of it as like someone writing a novel. You know, how do they write? Do they use long sentences or short sentences? Well, there's something that is analogous to library, which is this require package. Long story short, there's no difference here, actually. I vaguely recall, I think it's better to use library maybe because it's more conventional. You could also use require though, actually. And in fact, to be fair, if you notice, I didn't even include quotes for the package name Mosaic. I like it because it's conventional. I like parallelism. Parallelism simply means if you do one thing one way in the beginning of your code, you do it the similar way in other parts, just for consistency. It reduces error, it improves readability. That's my preference, so it doesn't look like 10 different people had written it. Of course, when there are 10 different people writing the same code, then it probably will look like something like that. Now, let's talk a little bit about this R thing, this Mosaic package, by the way. If you notice, I highlighted it, and what I like about RStudio as well, if you use Python or other kinds of scripting languages, or even statistical software packages, it'll do some autocomplete things for you. Notice when I highlight this, it'll also highlight the other Mosaic words in the script. But I'm also going to just put this in quotes. If I can highlight the entire word, and then I just click Shift and then quotes, and I just put quotes around the entire thing. But require is essentially the same thing as library. Now, there's also another way to install packages, and this will get us to this concept of what this Mosaic data package is. If you go to your pane, and it might depend on where you are, there's actually a pane that shows all the kinds of packages you have. Now, when you load the Mosaic package, keep this in mind. R has packages installed as part of its system. These are called base packages. Then there are also many other kinds of packages that are very commonly used. A very common one, for example, is this package called CAR, the companion to applied regression. If you notice what I have, you'll probably see I probably have a lot more packages than you because I've been using a bunch of other stuff here. But you can see that a lot of these packages right here are installed because I use the install packages function, but they're not loaded. And in fact, if I want to load a package without ever using the syntax, you can just go to the packages pane here, and we can go and install them just by clicking on them. So if you look here, look at Mosaic. Project Mosaic Statistics, Math, and Mathematics Teaching Utilities. Well, it's clicked on because I installed it. What will happen when I unclick it? Oh, well, it looks like I uninstalled the package. Well, in fact, that's what you do here, and that's using this detach function. And you basically you're saying you detach the package Mosaic, you unload it. That means it's true. That also means that when you reload, now let's do the opposite. If we want to install the Mosaic package without having to use syntax, using the library function or the require function, let's click on it and see what happens. All right. There we are. You'll notice there's a little bit more junk here in essence, right? You can see, whoa. Sorry, I highlighted the wrong bit of text there. if you look at this, you'll see some interesting comments here, which I think is interesting. It says the Mosaic package masks several functions from core packages in order to add additional features. The original behavior of these functions should not be affected by this. Basically, what it's saying is it gives you a little bit more information. It gives you a little. Sometimes it'll give you a warning. By the way, when you install a package, don't worry about it. Typically, I mean, these are pretty modest warnings. I think the version I have is version 3.4 or something like that. But I do want to show you that the library here looks a little bit more complicated, only because it has a sort of an optional command here, which is basically I did what I had before, but then but then it tells me where it is, and this is where almost all your packages are. All your packages are essentially where you installed R, and then your Win library. And so that's basically what happens when you use the install packages function. What you're doing is you're actually dumping these packages on your machine, but you don't have to have that extra script there. It's essentially the same thing. But that's something important to know. Now, if you want to install the Mosaic package and you don't want to, fish through it, you want to look through here. Now, this is what I said last time when we talked about loading the Titanic data sets. There are built-in data sets within R, and the Titanic data set that we have here is different than a built-in data set, because a lot of packages like Mosaic include their own proprietary data sets. Not proprietary, but their own data sets that they include. And when you install Mosaic, when you do this command right here, library Mosaic, you're actually also installing this other package, the set of project Mosaic data sets. And all you're doing is loading into memory data. And that's why, to ask the question, loading the Mosaic data, that's why you might see that command as well. And to see this, this is a little bit extra. This is extra credit. I just want to show this to you. Here are, if you just type in the data function, and with some options, you can look at other types of data. But there are a lot of data sets here that are installed within R, and you can see them with other packages. dplyr is a package I use, and we'll talk about that later. But I want to point down to here. Here are the data sets involved used in the Mosaic data package. Now, why do they include that? Well, sometimes when you go to a help file, they provide an example of a command, and they will say, well, here's the data set we use, and you can load that data set and see for yourself how to use the package. And here's the example of the data set. So these are the kind of data sets that they include right here. Later on, when we talk about probability, I actually use the cards data set, which is pretty cool. But there's some classic data sets here. What I want to I should also point out that a student's guide to R uses this the health and evaluation linkage to primary care data sets. And some of the tutorials I have will focus on that, because almost every one of the examples in the student's guide to R uses that data set. So that's built in. So it's really supposed to be a convenience function. It's not supposed to confuse things to have built-in data sets. Thanks, Scott. I appreciate that, and Antoine. But this is also useful later on, and I'm going to have a tutorial later on, because there are some really cool data sets, historical data sets. Like there's a data set on duels, there's a data set on breakouts of cholera epidemics. I think that's the package hist data. I could go on and on about that. That's really cool stuff. But I want to see where that Titanic data set is. Oh, you can even just look at this. Like, this is pretty fun. Here are the terms of 11 presidents from Eisenhower to Obama, right? Some of these are classic examples. If we can see where Titanic would be. I'm almost thinking it's in the base data sets, this first one right here. Yep, here we are. That's what I showed you yesterday, which is that if you just type in Titanic without really uploading our Titanic data set, you're going to get their Titanic version data set. Just as if you type in, I don't know, Lake Huron, you're going to get the level of Lake Huron from 1875 to 1972. But this is also good for thinking about your final project. there's so much cool stuff in R for cool data sets that you won't have any problem finding data. And I'm happy to share that with you. Okay, so last time we learned to upload the actual data set, and now I just showed you how more ways to load packages. You can use the graphical user interface or not. But while we're at that, let's go to that help function. And I have a video on help. We'll talk about that later. But there are ways to ask for help. For now, let's just focus on loading these packages and getting to the analysis. Last time we did this. We did the view function, which is like a little spreadsheet. And what I didn't show is that when you hover over these, you can also order, by the way, like I just toggled this age thing. You can order from largest to smallest, which is really cool, of the values within these cells, as well as the variable names. These numbers in that first column, those are just an index. Those are not in the data sets. And all they show you is that when you imported the data, what order do they come in? And you actually, I'm not even sure if I can reorder it back to the top. I'm not sure if I can do that, but you'll see that by reordering this, you can actually get a different order here. So yeah, you can see like some of these data are pretty depressing, I have to say, if you look at the younger ones who died. But here you get names. You can order the names by, it looks like alphabetical order, just by pressing that. Fair, you can get that from lowest to highest. Click it again, highest to lowest. Class, you get it by lower, upper. You can order all of these. So this is very convenient. I think you can also highlight this. I'm much more of a syntax person, so I don't really play around with this. But yeah, you can. Well, let's inspect that. No, what are you doing? Oh, when you inspect it, you can actually look at the source code here. That might be something I have in my web browser. The point is, there's a lot of cool stuff here. You can also filter, right? So let's say we want, oh, I don't know. My last name's Fossey. Let's see if there's anyone with Fossey. Nope. Let's try Astor. Jacob Astor is a very famous Harvard benefactor. And it looks like he passed away, but not his wife. So there are a lot of cool stuff you can do with just the filter function to get to know the data. Oh, and I just opened it in a new window. But anyway, play around with the view function. Have fun with it. So the names function, what does this do? These are the names of the variables. Okay, that's it. Let's get to what we're supposed to do this week and see how much time we actually have left now, because I feel like I can talk on and on. Okay, we have 20 minutes. We'll try to make this 25 minutes. All right. Are there any questions about how to do these analyses? Because I think if you just run through the syntax, actually I know this. If you just run through the syntax without knowing this, monkey see, monkey do it, as one would say, not to be pejorative, then you'll get the syntax, you'll get the results, and you'll be able to answer the questions. But what I want to show you is, which is important, is, let's see what we should start with. I'm going to focus on this tally function because this is also in the readings, the course readings. This is the essence, and you're going to see this function again and again and again. And the tally function is for analysis of categorical data. All right? And what the Mosaic package does is that it constructs every function, most functions rather, in a kind of equation, in a sort of equation format. So in the same way that you can diagram a sentence in English class, I'm going to diagram for you what this tally function does. Now I'm going to go to help, and I'm going to clear my console here so you don't have to see anything. And I'm going to show you the best way to get help for a function. Just do the question mark. Look, it'll tell you what you're looking for. And I didn't even click anything. And I'll tell you what it is already. Tally is a convenient wrapper. And wrapper, by the way, means that it's basically, there are other ways to do tally, categorical data analysis, but tally is easier. It's more intuitive. And that's what a convenience wrapper is in programming. And it's a way to it's a convenience wrapper for summarize, the function summarize, that will either call n or some number, depending on whether you're tallying for the first time or retallying. Count is similar but it does group by for you. It's a little technical here, okay? So it references the sum function and the count function, but basically it's for categorical data analysis. Let's press F1 here for additional help, see what it says, see what happens there. Well, they're having problems. I'm not sure what went on there. You should get it. Just oh yeah. Oh, here we are. So this will take us to our help pane. So notice here, it'll say help on the tally was found in the following packages. Now there are two sources for this actually, because dplyr is a common data management, data cleaning package. You'll see it there. But we want tabulate categorical data under the Mosaic library. So let's click that. Well, this is a great place to go for help. In fact, this provides lots of detail here. And this is, again, where if you look at these, one of the first things I do actually when I do this is I scroll all the way down and I look at the examples. And the examples here use data. Remember this health randomized control trial data set that we saw before with the data function? They're using that data set so that way we can run tallies, the tally function using their data. And you don't have to load anything, you don't have to do anything. And they use that just to help out. So I'll just even show you right now what that looks like. So you can already see this is basically a drug substance abuse among people. I think they're homeless people. And you also see, by the way, that this data set is not loaded in our global environment. Just as a reminder, once you join, could you please mute yourself just so the background noise isn't it doesn't sound, if that's okay. It looks like someone has some background noise. Do you think everyone could mute maybe? No? Okay, thank you. All right, thanks. So, okay, the point I want to make here is let's deconstruct what the tally function is for our purposes, for answering our questions. Well, the first thing we have here is the bar graph. We'll start actually with the tally function. I want to do this because this will answer the majority of our questions. Almost always with the tally function, think of it as a sentence. And this little thing right after that you see right after tally, this is a tilde right here. This is often used in equations. And what you're really saying is, my output that I want uses the variable class. And what do I want to do with I want to tabulate the categorical variable class, and I want to make it this format. And that format will be a count. And notice I put the word count in quotes here. And there are other different kinds of formats to make it. And I'm going to use this data set. I'm telling which data set to use. So if you notice, if I put these on separate lines, separating them by a carriage return, you can see that here we have a function tally that uses the tilde function because you're saying the outcome that I want is a result of the variable class presented in the format of a count using the data set Titanic, and the close parenthesis says that's the end of my argument. And that's all that we're doing. So what we're going to do is we're going to get counts of class using the Titanic data set. We're not using the built-in Titanic data set, we're using the one that we loaded into our global environment, and you can see that right there. And you press carriage return, and you see that that's the case. We have the count by class. Now, of course, there are different options here. We can use different data sets, we can use different variables, and we can also do other kinds of combinations. Another option we can do is the proportion. So if we do that, then instead of counts, we're going to get the proportion of passengers within each class, not the counts. Now here we see a level of exactitude that is a bit much for us, right? But what does this show? Well, a proportion, remember, it always adds up to 1 if we have all proportions in a sample space. So what we see here is that 0.48% of the Titanic passengers were in the lower class, right here. 25% or 0.25 were in the middle. 27% or 0.27 were in the upper. Now, probably an easier way to do that is just to type in %. Okay, and what will % do? Well, it'll give us proportion, only it'll give us, in a more intuitive way, the percentages of people in each class. So keep in mind, there are 3 ways of doing format, right? There's the count, there's the %, and there's the proportion. And now we can do this with other variables, and we can do this with other data sets. Notice that with the exception of class, these others have an equal sign. You're saying the format equals this, the data set equals this. And that you also notice that the arguments, aside from the last one, which is ended by a closed parenthesis, each of these little segments is called an argument. It's like these are like little bits of a sentence. You're saying, well, my first argument is first thing I want to say is this. Second thing I want to say is this. And the third thing I want to say is this. And that's really the same structure for every single analysis. So we're going to do this for the other. Oh, now we're going to do something a little bit different when we look at a tally of by different groups. Now, what we have here is a pipe or a vertical bar when we use the tally function. And the third question we have is, based on this data set, what proportion of men survived the Titanic approximately? Why is there a little red thing there? Okay, good. Well, what are we doing here? Well, we're changing things up a little bit. We're basically saying we want to know those who survived conditional on gender using the proportion format and the Titanic data set. And we also added something else, which is margins equals true. Well, we actually already had that argument here in the tally function, which was margins equals false. All margins means is it's the total of whatever it is you're adding up or whatever you have in your analysis. So there are often defaults that are kind of hidden. So I want to show you first what happens when you set margins to false. Remember, we had this count before. That's what you had when we showed the percentages without even including this argument. Now, when we include margins equals true, what we're going to show is what all these percentages add up to. You have the total. So margins, all it does when you set margins to true, you're just giving the totals. So tallies you can look at one variable, but here we're looking at 2 variables. And I want to show this to you first. I'm going to clear the console just for clarity. And if we look at this argument 3, we show that survival comes first. And what we're saying is that our proportion of survival based on what gender you are. That's what we're tabulating. First, we're going to find out what gender you are, and then we're going to find out whether or not you survived. That's what this little pipe here says. So basically it says, given that we know what gender you are, what is your survival? Given that you know what gender you are, what is your survival? That's why order matters here. We're not saying, given whether or not you know that you survived, what is your gender? We're saying, we know gender first. And that's what we see here. And that's why the totals or the margins are all the way here at the bottom. And that's why those add up to 100%. Because we're doing the proportions within gender of survival. So that's why the order matters here. And then, so what I'm saying here is that this is a way of saying conditional on gender, male or female, we provide you with the survival rates. Conditional on gender, we give you the survival rates. And that's why when you set the margins or totals to true, they equal to 100% for each subgroup, because you're taking the men into one group and they equal 100%, and then you figure out the percent survival. Then you take the females, you figure them out, and you get the survival, and you figure that out. And that's why order matters. And I'm going to show this to you because let's just put it the other way. Let's do this incorrectly. Sometimes you can figure something out by doing it incorrectly. So this would not answer our question, because what we're going to do here what this shows is based on your survival, conditional on survival, what is your gender? Well, that's a little bit different. That's a different question. Somewhat similar, but very different. And that's why you get different percentages. Right? So we show that among those who survived, 68% or 0.68 survived. And among those who did not survive, about 60% were female. So this is why the pipe, when you use the pipe function to condition on some other variable, that's why that order matters. Margins, again, is just a fancy word to say true. It's sometimes called margins because really, if you think about it, if you made a little plot with this is just sort of like an afterthought. We kind of already know that you take this and you add this, you're going to get 100%. So that's the way I sort of think about it, but that may not be the most useful. Now, we do the same thing here. We say among those in the lower class, in other words, given that we conditional on class, what is the proportion of survival? This is why we have class first, and then we have survival afterwards. Are social class and surviving the titanic related to each other? Well, here we have the same command, and all we're doing is we're just trying to see whether or not those vary. I want to show, let's see if I covered this. Oh, yeah. I already showed how to do graphs and figures using the proportion, the count, and the percent differences. Yeah, I want to go back to this bar chart function. Unless you have any questions about using the tally function to create conditional probabilities or conditional percentages. Do you have any questions about using that tally function for that? If not, we'll proceed. I'm glad we actually went a little bit faster today than I thought. Okay, so if we look at question 2, we actually had a bar chart here. It's relatively easy, but let's go to the bar chart all the way down to the bottom. Oh, I'm sorry, wait, the bar graph or bar chart? Hold on for a second. Yeah, bar graph, I'm sorry. Yeah, that's the function bar graph. No, so this is why Mosaic is a convenience wrapper. It's useful. Notice we have the same thing. We have, basically we have a function, we have an open parenthesis, we have something with a little tilde, which says, sort of like an equal sign, what we want equals variable name. See, it already thinks this is a command. You separate it by a comma, and then you typically have something like a data equals data name. And then quite often that's about all you need. Sometimes you'll need something else like a format. But this is called like an equation format of doing an analysis. And I notice I made this is a useless function. This doesn't do anything. But I'm illustrating this because this is, think of this as make this familiar to yourself. So, and that's how you basically make the bar chart here. Pretty simple. And I want to show this to you. You make the bar chart. Someone asked about this. You want to make sure you go to your plots pane here to see the bar charts. Here's a bar chart of counts. And if you want to export this and save it, you can save it as an image, copy it to a clipboard, put it somewhere else. But that's where you're going to see the graphics. You're going to see the graphics in the plot pane. You're going to see the tables or the analyses in your console pane. And there you can just cut and paste, actually. If you want to cut and paste that elsewhere, you can copy that. So I think we got everything covered in terms of the tally options in terms of creating a bar graph. Here's something a little more complex, which is making a pie chart. Pretty common to do a pie chart. I would honestly, if you want to do a pie chart, what you're doing here, intuitively on line 75 right here, I'm going to talk about this later, but you're using this thing called an assignment operator. All you're saying is you're going to create something that is, you're basically going to tabulate the counts by class in the Titanic data set. And by the way, all of this to the right of the assignment operator should look very familiar. You're tallying the variable class using the format count with the format count using the Titanic data set. All the assignment operator says is everything to the left of that little arrow, it's basically a little caret and then a little dash, a hyphen. You're saying, we're going to call that counts. And the reason you want to save it that way is then you can make a pie chart out of it using the pie chart. So first you create the counts right here. And you have that right here. Look at this. You created something that is a table of the counts. And you have that there. Now, what you can do with that is you assign the little pie function there. Notice, by the way, this deviates from the equation formats. Not everything in the Mosaic package follows that, because not everything in R is built that way. And also, pie charts aren't often used by statisticians. We don't like pie charts for many reasons. It's controversial. On the other hand, I use pie charts all the time because that's what people like. So here we're doing a pie chart for indulgence. But there are a couple of reasons why we don't like pie charts. I mean, if you use it, by the way, if you create multiple plots, and in the plot pane, you can toggle back and forth. See that? You can go backwards. We can look at the former plot we had. So here are the counts of social class by lower, middle, and upper class. And here is lower and upper and middle class by counts using the pie chart. Any reason why we might not like the pie chart as much as this, the bar graph of counts? I can tell you why I don't like it. Counts lets you see what's the relative size of things. It also gives you a relative number. About 500 were in lower, middles and upper were pretty close. It's really, you can kind of tell here, but it's harder to see. And there's no axis here that gives us like the actual relative magnitude, right? Here you have a number, 500. I think that's more powerful. Of course, like everything else with graphics, there's room for debate. Some people love pie charts. Statisticians, you'll typically encounter that they typically don't. Yes, exactly. Thank you, Scott. Hard to visualize the difference. That's the whole point. And in fact, this is what Edward Tufte, the very notable guy, if you want to look up a sort of a statistical hero, he would say that the reason he hates pie charts, and he's probably the biggest reason we don't use pie charts, he says there isn't this interocular effect. That's the jargon that he used. Let me say type it. Interocular effect. What does that mean? I'm guessing he meant by this, with your eyes you can see the difference. It's the proof's in the pudding. Here, if you want obscure class differences, maybe if you're maybe if you're in the shipping industry and you wanted to minimize the impact, you could sort of say, this is how you lie with statistics. You could sort of show a pie chart that sort of says, yeah, it's a little bit higher, but they're all pretty large groups. But if you look at this, it has a larger visual impact. It also has numbers. It's also more informative. Anyway, we could talk more about that, but we, unfortunately, there's so much to learn. We can't do everything. I want to do one last thing, which is that we didn't get to the Mosaic plots. Darn, I wanted to get to that. Let's see if we can get to the Mosaic plots. What I want to talk about is, okay, Antoine, I'm going to quote you, if you don't mind. Antoine made a good point. He says, another way to put it, pie charts are best to use when you're trying to compare parts of a whole. Very good point. Thank you. This is the debate I had with a friend of mine. He loves to use pie charts. He said, well, maybe you want to cut things into bits of a pie. You want to know parts of a whole. But they do not show changes over time. True. Bar graphs are used to compare things between different groups or to track changes over time. Very good point. If you want to show changes over time, yeah, a series of pie charts by year don't really work. This is atemporal, but it's also to show differences. But yeah, it's also true. That's a very good point, Antoine, because if you want to show the decomposition of a group, yeah, pie charts work. And in fact, I'm writing a paper where I'm using pie charts because I think we agreed, if we were trying to decompose income gaps between racial groups, and we wanted to decompose what was the proportion of the income gap attributable to discrimination. So you want to decompose something, look at the pieces of the pie, that's useful. But if you want to show differences between groups, that's relevant. So that's the best way to take things with statistics. Let's go back to the tally function. I showed how to create a count or a proportion or analyze one variable conditional on another. That meaning that given that we know one variable, say gender, we want to know the percentage who survived or the proportion who survived. Now we're going to do a contingency table, and this uses the plus operator. That's the only difference. In fact, I want to make this so similar. I'm going to do gender and survival again. So I'm going to reuse our gender and survival variable. I'm messing around with the syntax, I know, but let's visit this. And now I'm gonna clear the console, and we're gonna do our contingency table. I'm gonna do percent, by the way. People like percents, and that's a little more intuitive. So first, I'm just repeating what we did before with this pipe or this vertical bar, which says conditional on gender, what percent of passengers survived. Okay. Now, what happens when we do this plus operator? I'll show you. And of course, it doesn't answer question 3. Well, what does it show? It actually shows the joint probability of being male and not surviving. And so the big difference here is rather than say conditional on one group or another, sorry, conditional on gender, what is survival? It says, what is the probability of being of a gender category and a survival category? So the plus operator gives you joint probabilities, and the conditional probability gives you the probability of the one variable given another. And you know this because the total here adds up to 100% only in the right-hand corner, as opposed to when we use the pipe operator here. I don't think I'm explaining this as well as I'd like to. So I want to show this one more time. I'm going to scroll up here. We're going to show the difference between a contingency table, two-way contingency table, and a conditional probability table. A conditional probability table has two totals of 100% because you basically split the group into one category and figure out the probabilities. A two-way contingency table says, okay, we're not splitting, we're looking at everybody, and we're saying, what is the probability of the intersection of two categories? So what is the probability out of the entire sample of being male and non-survivable? Or what is the probability of, or the percent of men who survive, of survival and being male? And we know this to be different than a conditional plot, because each of these joint probabilities right here, these add up to 100%. And that these subtotals here are simply the addition, the additions right here. And these subtotals also add up to 100%. So you take the probability of female and not surviving, which is about 9%, and then the probability of male and not surviving, which is about 50%, well, you get about 59%. So with the total here, this is simply the probability of not surviving. And then you take here, this is the joint probability of female and survival, the joint probability of male and survival. By the way, notice I'm using the word probability, even though we're talking about percentages, because in future classes, we're actually going to talk about using these contingency tables as probability tables, because that's what we're really talking about, whether it's a percentage or a proportion. Technically, we should be using proportions here, because a proportion, a probability, is a fractional, is a decimal place. But I'm just using percentages here because I think they're a little more intuitive. So that's the biggest difference here, is the information that they provide. So if you look at here, you see male, the probability of being male and survival here is 20%. Well, that's because it's not a joint probability. What it is, it's the probability of survival given that you're male. So here, the way I think about it is, again, look at this total here. You take the group, pair it off, or pair it into categories, then you calculate the probabilities or the percentages. Whereas when you do the two-way or multi-way contingency table, you're saying, let's take everybody and look at the intersection of those categories. If you're male and if you're male and you survived, what is proportion of the sample is like that, or what is your probability of that occurring to you? And that's the biggest difference. And I should also say, when we talk about the two-way contingency table with that plus operator, does order matter? Well, not really, because, and I'll show you, it shouldn't matter, because whether or not you're male and you're not survived, all you're doing is you're looking at the intersection. It's a conjunction, or the combination of those two variables. It's nothing conditioned on something else. So let's do this with the plus sign, and we're gonna I'll show you how order doesn't matter, because here we have survived and then we have a gender, and it should look like this one right here. And if I'm wrong, well then, shame on me. So what is the probability? So if we look, it's a little confusing. I'm going to clear the screen a little bit. What I want to show to you is simply that order doesn't matter when you look at the assignment operator, when you look at two-way contingency tables or joint probabilities, because you're just looking at the conjunction of two factors, two variables. So here we have gender and survived. Here we have survived and gender. And here we're going to see the same table. The order is going to be different. Oh shoot! I want that screen clear. Oh, there we go. So here we have two-way contingency tables, and we'll see. Let's just take a look. So this is the one we've been looking at. The probability of survival and being female is 28%. Here, well, the columns and the rows are different, but the probability of female and survival is still 28%. It's just located a little differently. So all you're doing is switching around the columns and the rows, but it doesn't matter because the order doesn't matter, as in contrast to that pipe operator, which really is a statement about what it is that you want to divide by into groups first before you calculate the proportion or probability or whatnot. And that's, I think, the key point here. We didn't look at Mosaic plots, but let's if we're going a little bit over, we're a little over, but it's fine. I'll show you the Mosaic plots. But you can look at some of these. But here, I'm a little ambivalent about Mosaic plots only because a lot of people don't like them. But I think you should know what they are, and I want to illustrate them to you. So I'm going to use this gender and survival variable as we have done before. So if we look at this last tally command, here we have your probability of surviving and your gender. So let's do, let's rewrite this command here. And the Mosaic plot, it looks the function should look very familiar, because here we have a tilde sign. Antoine, what do you mean you want to be friends with him? You want, is that a typo? Do we all want to be friends with Mosaic plots? If we want, oh, okay, all right. Well, the point here is, okay, there are some options here, but what is a Mosaic plot? Well, it's a different way of actually presenting our table here, actually, because what you do first is you split the group by proportion of gender, because we know actually, you know what I'm going to do? I want to make sure that we only have here. I'm going to give you the table. I think the best way to understand Mosaic plot is to actually interpret it side by side with the actual function, because all it is a visual representation of the contingency plots that we've been doing. That's all it is. And when I say that's all, that's still quite a bit, because if you understand a mosaic plot, it's helpful for visualizing things. So let me clear the screen, and I'm going to actually I'm gonna do a little trick here that will just make life easier for us, and we'll talk about rounding later. But I just want to make the numbers a little more interpretable here. I rounded the percentages to smaller proportions here, but here we have a two-way contingency table of survival and gender, and it looks like here. I'm gonna switch this around so that way the axes are the same. Hold on for a second. Okay. What did I do? Was it an error? Sorry about that. Ugh, I don't know what I did. Here, we'll just redo it again. Oh, I see what I did. Okay, that's fine. We'll just do this. Okay, I'm going to rerun that script. Okay, so what we have here is we have the total probability of proportion of passengers who are female were 37%, and that's what you have here. What the mosaic plot does is it first divides on the x-axis the proportion by the length of that line here, and so that's why this is actually about 40% right here. And then it takes the second category of that variable, other categories, and you'll see that that's why the rest of the line is about 60% of the length. So this length is divided in proportion to the relative frequency of the entire sample. Now, what happens here on the survival axis is, what's that? So I'm looking at these totals, these margins right here, right? But then what it does is it basically, after it does that, then it tries to calculate the area of the each box is the, how do I say it? The joint probability in relative to the size of, the area is proportional to the size of the joint probability of each category. So gender, we know, is about, divided 60-40. Survival here changes by the category. So this is actually, this is one reason I actually don't like the mosaic plot, because it uses this little plus operator. It's actually more of like a contingency table, if you remember, because what this shows is conditional on gender. We then figure out how high or what the survival rate is on the y-axis. Technically, it's not a contingency table because the area itself is how large each group is, because it's two-dimensional. So what a mosaic plot does is basically, if you think about every, how do I put it? If you think about what a mosaic plot does, it gives you the relative size of each joint probability. So let's go back to our contingency table here. What's the largest group of that we have here? Well, these are men who died. Well, here we have 50% of all people were men who died. I think that's about 50% of the area right here. It also tells you, well, what's the second largest group? Well, it's hard to tell, but it looks like females who survived. Well, that's about 27%. The area of the mosaic plot is written here. So it gives you, in a way, it gives you both the conditional probability based on the x-axis, but then it also gives you the joint probabilities as expressed by the area. And intuitively, you can sort of see, just if you sort of squint your eyes, you can see, well, which group is more likely to survive? Well, it's females. But which group was larger? Well, it's males, because look how much wider that is. That's a larger group. So it gives you, I think, relative probabilities, but it also gives you absolute joint probabilities as well. A lot of people don't like the Mosaic Plot because there's something called the data to ink ratio. If you print this out on your computer, that's a lot of ink. You'll burn through your ink cartridges quite a bit. So there are quite a few people who don't like Mosaic Plots for this reason. I've tried presenting them. They seem to confuse people quite a bit, but I think it's useful, and I recommend you use them because I think it's a good way of getting both sort of visualizing the magnitude of certain groups and also the contingency of different variables. So it gives you sort of a nice combination of both kinds of information in ways that you can't necessarily see with this kind of plot here. This is good for exactitude, but this has good, visual interocular proof. So one last thing is you'll notice I did this little round function just to reduce the complexity, the number of decimal places. I'll talk about that next time, but I think we went through almost everything. We went through bar charts. We went through the Mosaic plots. We went through the tally function, and we sort of dissected what each of these elements are, these arguments. And I even showed you how to make a pie chart along the way, and I think that's it. And we can talk more about Mosaic plots later. I think there's a lot more to be done with those, but that's it for now. I hope this was helpful for you. Are there any questions before we end? Otherwise, thank you. Thanks. Oh yeah, of course. Yeah. Thanks for calling this a supplement to Monday section. This is what I see. This as part 2 to Monday. So if you haven't seen Monday section or the previous section I showed you how to upload the data. This is digging deep into the arguments and the analyses. And from here, you should be able to do the problem sets. And feel free to always ask questions about any particular issues and aspects that we follow up with. Thanks a lot, and keep abreast of the tutorials. And keep in touch. I'm going to stop recording, but if you have other questions once I'm done recording, let me know.